Now that we've had a look at theoretical and experimental probability, we're going to take another look at combinatorics and use combinatorics eventually to determine some probability. So remember that combinatorics is when you use the fundamental counting principle. So you just take a look at what you're dealing with and you multiply all of your objects or all of your outcomes together. So our first example for fundamental counting principle was how many outfits can you make if you've got 4 pairs of pants and 5 shirts. You just multiply the number of pants by the number of shirts. When we're dealing with permutations, that's when order matters, and things chosen are at a time when order matters. And then combinations are when order doesn't matter. So we choose n things are at a time, but order doesn't matter for combinations. Let's take a look at this first example. What is the theoretical probability of being dealt exactly 2 sevens and a 5-card hand from a standard 52-card deck? Well, the first thing we need to do is look at the number of combinations of 2s if we're looking at a deck that has, or combination of 2 sevens from 4 sevens. Okay, so what we're going to do here is we're going to take 4 of those sevens and choose them 2 at a time. 4 of the cards from the deck would be 4 because there are 4 sevens. There's a 4 of hearts, a 4 of diamonds, a 4 of clubs, and a 4 of spades. Choose 2. And I'm going to do a combination here because the order doesn't matter. I'm going to come back to that computation in a minute. Now, the number of combinations of 3 non-sevens from 48 other cards, what is that number? So again, we're going to choose 3 cards. Actually, no. We're going to look at 48 cards, and we're just going to choose 3. So these 3 are going to be non-sevens. 48 is 52 minus those 4 sevens. And so that will give me the number of combinations of 3 non-sevens from the 48 other cards. And then next up, how many ways can we get a 5-card hand with 2 sevens? Well, here I'm going to multiply those things together. So I'm going to choose 2 of my 4 sevens, and then I'm going to choose 3 of the other 48, and the order doesn't matter. So if I figure out both of those numbers, I can multiply them together and get the number of 5-card hands, the total number of 5-card possibilities with those stipulations. So we've got 2 sevens and then 3 non-sevens. So I'm going to open up my calculator right now. I'm going to actually calculate these values. So to do that, I go to math. I'm going to go over to probability. That makes sense. I'm going to choose number 3, and I want to choose from 4 things 2 at a time. And that gives me 6. Then I'm going to do the same thing for 48, choose 3. So math, over to probability, choose number 3, 48 things, and I'm only choosing 3. And that gives me 17,296. So to figure out the number of 5-card hands that have 2 sevens, I'm going to take 6 times 17,296. And on my calculator, that will tell me 103,776. I don't need to show you how to multiply on the calculator. I know you know how to do that. All right, so now let's take a look at the number of possible 5-card hands. So now there are no stipulations, like we're not looking for a hand with 2 sevens. So the total number of possible 5-card hands, what do you suppose that combinatoric will look like? Well, we're going to take 52 cards and just choose 5. Well, 52, choose 5, where the order doesn't matter. Again, math, over to probability, choose number 3, 52 cards, choosing 5. That gives me 202,598,960. So let's take a look at the probability of a hand with 2 sevens. So back to our definition of theoretical probability, we're looking at the probability of a 5-card hand with 2 sevens. And then how many event outcomes would there be to make that happen? Well, that would be 103,776. And then what are all possible outcomes? So all possible outcomes is this 2 million number, 2,598,960. So then do the division, and you're going to come up with 0.039, or there's like an approximately a 4% chance that if you were dealt a 5 card hand, you'd have 2 sevens. So let me say that again. There is about a 4% chance that you would be dealt a 5 card hand with 2 sevens. So would you go to Vegas and bet on that? I don't know if I would. All right, let's look at another example. And in this example, we've got a class with 147 students. 95 are taking math, 73 are taking science, and 52 are taking both math and science. We're going to choose one student at random and then find each probability. So what I'm going to do in the space below this problem is I'm going to make myself a Venn diagram. And so you probably remember that a Venn diagram is circles like this, and then I'm going to include it in a big box, and this box represents the sample space. Okay, let's see if I can make those a little bit more even. Okay, so these are all the students. This is the number of students taking math. This is the number of students taking science. This is going to be in here, math and science. And so then what do you suppose out here would be? This would be not math or science. So what do I know for sure? I know that 95 are taking math. So this business right here is 95. I know that 52 are taking both math and science. So Justin here is going to be 52. And then 73 are taking science. So this much right here is 73. Now what I'm going to do next is I'm going to subtract 73 minus 52, and that gives me 21. So this difference is the number of students that are only taking science. Okay, now I'm going to erase that because I don't need that number anymore. All right. Then the next thing I'm going to do is subtract 95 from 95 minus 52, and that gives me 43. So what that means is that only 43 students are taking only math. So 43 students are taking only math. And then I don't need this business anymore because I kind of dealt with that. So we know that in a class of 147 students, if there's 147 students, I'm going to do some scratch work over here. 43 are just taking math. 21 are just taking science. And then 52 are taking both math and science. So the difference will be 31, and that means not math or science. So this number out here is going to be 31. Okay, so hopefully this Venn diagram will help me as I come up with my probabilities here in A through D. So what is the probability of taking a math or science class or both? So that's going to be pretty straightforward. If you're taking a math or a science or a both, remember that that adds up to, I don't know what that adds up to, 43 plus 52 plus 21. And then remember we're talking about a total of 147 students. Well, that's going to be 116 over 147. And when I do the division, I get a 0.79. So that means there's a 79% chance that a student at this high school is taking a math or a science class, or both. Next up, let's take a look at the number or the probability of a student not taking a math class. Well, if they're not taking a math class, then maybe they're taking a science class, or maybe they're not taking anything at all. So I'm going to take 21 plus 31 and divide it by the total number of students. And that gives me 52 over 147 as a decimal, 0.35. So there's a 35% chance, almost a 1 in 3 chance, a little more than a 1 in 3 chance, that a student isn't taking math. That's a bummer. Shameful. Their guidance counselor should get their head on straight. So now let's talk about part C, taking math but not science. Oh, my favorite students, taking math but not science. So there are 43 that are taking just math. There are 52 that are taking math and science, but remember, we're looking for not science. So that's going to be 43 out of 147, 0.29. And then finally, what's the probability that a student is taking neither math nor science? Well, we know that that number is 31. And 31 divided by 147 is going to be 0.21, or about a 20% chance that a student isn't taking a math or a science class. Again, oh, what a disservice we are doing to those students there. Okay, so that takes care of that. We used combinatorics to kind of figure out what was going on with our deck of cards and dealing out hands. And then we used a Venn diagram to organize our information so that it was easy for us to find those probabilities. And then tomorrow, we'll take a look at some more practice here and then talk about when multiple things are happening and how we can calculate those probabilities. All right, good work, team.